Good day and welcome to our science virtual class. I am your teacher, Ms. Jihan Simon, and today we are going to see electromagnetic forces from your Elevate Science Physics book, Pearson Realize. This is Chapter 7, Lesson 3. Electromagnetic Principles. The vocabulary is right here. Please submit the definitions into our Google platform. The relationship between electricity and magnetism is called electromagnetism. Electromagnetism was first discovered by a scientist named Hans Christian Ørsted, and he took a compass to the classroom, and when he was near an electric current, he noticed that the compass would start moving. The needle would start moving towards the current. And he then tried this experiment several times and saw that all the times the needle of the compass would move towards the current, creating a magnetic field. As you can see in Figure 1, this is an example of a magnetic field. A regular magnet is not strong enough to pick up these heavy beams. This special type of magnet, called an electromagnet, has the strength to do it. Magnetic fields and currents. Magnetism from electricity. As you can see, this figure is trying to show us that all the compasses, when they have a magnetic current, are going to go in the same direction. Magnetic fields around straight wires. In a straight wire, the field's direction depends on the direction of the current. To change the strength of a magnetic field around a current carrying straight wire, change the amount of current running through the wire. For example, in Figure 3, we can see the right-hand rule. Imagine that you are holding the wire in your right hand with your thumb pointing in the direction the current flows. The direction of the magnetic field is the same as the direction that your finger curls. If current is increased, the magnetic field becomes stronger. If the current is decreased, the strength of the magnetic field decreases. Solenoids and electromagnets. Solenoid is a coil of wire with the current running through it. Is similar to stacked loops of wire. In a solenoid, the magnetic field is strengthened in the center of the coil when a current runs through the coil. One end of the solenoid acts like the north pole of a magnet, and the other end acts like a south pole. You can see in Figure 5, this image shows the magnetic field lines around the solenoid. These are the loops, the stacked loops that they were describing before. Field strength and solenoids. You can increase the strength of the magnetic field inside a solenoid by increasing the number of coils or loops of wire. Winding the coils together also produces a stronger magnetic field. Electromagnets, like in Figure 6. A solenoid with a nail in the core is a simple electromagnet. More advanced electromagnets have many practical uses. For example, on your left, some doors are locked with electromagnets and can only be unlocked electronically. Electromagnets are used both to lift this train off the track and to propel it forward. An electromagnet helps to produce the vibrations in these earphones. These vibrations carry sound to your ears. Electromagnets. To make a magnetic field even stronger, you can add a ferromagnetic material. Ferromagnetic material is a substance that becomes a magnet when exposed to magnetic field. Please go to our Google Classroom and complete the assignments. Thank you, and have a great day.